Searching the open web and structuring that data into accurate tables is one of the hardest challenges for LLM agents. Monolithic systems either get context-saturated on wide searches or lose reasoning depth on complex queries. Enter Web2Big, a multi-agent framework that solves this with a bi-level architecture and purely memory-based learning. Instead of a single agent trying to do everything, Web2Big factorizes the policy. An upper-level orchestrator decomposes complex queries into independent subtasks, while a pool of parallel workers executes them simultaneously. They coordinate through a shared Markdown workboard. Think of it as a live working memory. Workers read each other's partial findings, skip redundant searches, and dynamically fill coverage gaps without explicit synchronization overhead. Here's the real innovation. The system evolves without touching a single model parameter. After each run, a verify-reflect pipeline compares the output against ground truth, distills errors into structured reports, and appends new decomposition and execution strategies as human-readable Markdown skill files. The underlying LLMs stay completely frozen. All adaptation happens in persistent external memory, meaning the system improves through context and file updates rather than gradient descent. The results are stark. On the WideSearch benchmark, it hits a 38.5 average success rate at 4 runs, beating the next best system by 7.5 times. It also generalizes to deep reasoning tasks, hitting 73% accuracy on XBench-DeepSearch. The takeaway: when you combine hierarchical task decomposition, asynchronous shared memory, and parameter-free skill evolution, you don't just scale web search, you fundamentally change how agents learn to reason at internet scale.